Hello there and welcome to another drive-by coding session. So Waikit is learning to use the Canvas API and we're gonna see what he does. So again, for the uninitiated to Canvas programming, there's a grid. You first create a canvas of a certain size, and then within that canvas, the rectangle that are the bounds of the canvas, there is a grid where the coordinate system is starts at 0, 0 at the top left corner of the rectangle, and then the x direction increases as you move from the left to the right of the canvas, and the y direction increases as you go from the top edge of the canvas to the bottom edge of the canvas. All of this is well documented on the MDN Web Docs website. So to find this, all you have to do is type canvas and MDN, and you should find this information. Again, Waikit likes to use TypeScript, and he uses this web template, which is available on GitHub at this URL, where you just download these files as a zip file and drop them into your project, and then npm install, and then you're ready to go. So let's see that. So again, Waikit gets started. He does create a .gitignore file so that Git doesn't check in the node modules folder, and then he drops in these files from the template and then does npm install. There we are. And then he does npm start in order to start the Webpack dev server. We shall do that as well. So you can see the app. And there is the app as it looked when Waikit started. This is more or less what the web template gives you. So again, Waikit starts off by creating a canvas. The width and height of the canvas have again be set to 500 pixels each. And then there's a black border so that we can see where the canvas is. Again, in order to draw on the canvas, you need to create a context object. This time he just abbreviates this as CTX. This time Waikit is going to experiment with the concept of paths. To illustrate paths though, first he strokes a rectangle. Now in fact this stroke rect, it strokes a rectangle, but internally what it actually does is it does this by using paths. So, and we can do the same thing by using the path API, which works like this. So first you begin a path, and then you're gonna draw a series of, well, paths, for lack of a better word, on the canvas. And then when you're happy with the shape of the path, in this case, we're gonna use the rect method. So when you call .rect, that is actually different from the stroke rect method, whereas the stroke rect method, that's really hard to say. Stroke rect actually strokes the rectangle. The rect method does not do that. All it does is defines a path based on the rectangle as specified. And then when you call that stroke, that's when it actually strokes the path that has been defined. So let me illustrate that by commenting out the stroke. Yeah, so if you don't stroke, it doesn't actually stroke the rectangle. Now again, we can use stroke style to influence the color of the stroke, both for the stroke rect method and just the stroke method. Now this is good. I mean, so far all we've done is made this process of drawing a rectangle more tedious. But to see the power of paths, we need to see what you can do other than drawing rectangles. But we're still gonna draw a rectangle. So this method again is a helper function. This rect method is still just a helper function for some more lower level operations that the canvas is doing for you. And we can rewrite that as a series of move to and line to operations. Because in order to trace the outline of a rectangle, what you're actually doing is first moving to a point of the rectangle. In this case, let's move to the top left corner of the rectangle. That's over here. And then you say, I want to trace a line from that point, 100, 100, to 300, 100, which is the top right corner of the rectangle. And then move the line down to 300, 300, which is the bottom right corner. And then move the line over to 100, 300, which is the bottom left corner of this rectangle. So we have traced out a path, and when we stroke it, it actually does stroke the path that's been traced out. I'm gonna comment out the last segment. Yeah, and if I wanted to draw just the first two segments, it can do that. Or if I just wanted to draw just the first segment, it can do that. Now we have just a line. To finish off the square, then I finally move back to the place where we started at the end. Move back to 100, 100. So these 5 instructions is equivalent to this one instruction, context.rect. There's a bit of a shortcut. You can instead of explicitly writing a line 2 back to the beginning of the path, you could also say close path, which will automatically go from whatever point you currently are back to the beginning of this segment. So that just makes it so that you don't have to do this final closing of the path yourself. Let's see what Waikit does next. Okay, so Waikit drew yet another square here at the lower right corner of the canvas. And what he demonstrates here is that you can have one path that traces out more than one shape at a time. And then with one stroke method call, you can actually stroke both of those shapes, because both of these shapes are contained within the one path. So first, these 4 instructions trace out this bigger square, and then this code actually moves the current point to 400, 400. So it kind of skips. So like after the first square, it ended up at the top left corner of the first square right here. And then it moves to 400, 400, which is top left point of the smaller square. So it kind of skips. So it's actually possible for a path to skip inside of the path to some other place and then draw a different shape. So yeah, so he made this second square a little bit smaller. That's cool. Okay, now question for you, my viewer. How do you draw a rectangle? Given this code here that uses a path to draw a rectangle, what is the smallest number of change you can make to this code to make it draw a triangle? So if you want to pause the video to think about it and to come up with an answer, you can do that now. I'll give you a couple of seconds to decide whether you want to do that or not. Okay, so if you did it, congratulations. You made good use of your mental thinking time. Or if you just want to enjoy the show, just remove the last two lines. So this code here first moves to this top left corner of the would have been square, then moves to this elbow point, which is 300, 100, and then moves to the 300, 300, which would have been the bottom right corner of the square. And then it closes path immediately instead of moving the line to the bottom right bottom left corner. It just closes path immediately, which causes it causes the path to draw back to the top left corner, and thus we have a triangle. And you can imagine drawing other triangles or other even polygons using a path like this. Okay. Now let's see what Waikit does next. Okay, so Waikit wants to make a plot point function. I think this is so that he can just display a point on the canvas so that can guide him to whatever shape he wants to draw next. So how would you write a plot point function? Let's see what he does. So basically, this is what he wants. He wants to be able to call this function with an x and a y coordinate, and then that will plot a point for him. One word for those of you who are not familiar with TypeScript. So this function looks mostly like a JavaScript function, except for these two labels here. And this word number that comes after the colon tells TypeScript that the parameter that is passed into this plot point function must be a number, and the same for the y parameter. And TypeScript will enforce that for you to make sure you or another programmer that uses your function does not make a mistake. So for example, if I try to pass in a string here, that's not going to work. TypeScript is going to see that a string is not a number and complain about it until you fix it. By the same token, you cannot pass an array of numbers in here because an array of numbers is not a number. Okay, so so he just uses a fill rect. It's a very small rectangle, 10 pixels by 10 pixels, and he kind of does a little offset here so that he's like starts, because of the thickness of the point, he's moving back so that the point is centered on the x and y coordinates. He actually makes it 11 by 11 so that maybe to make it that center or something. So if we plot the point on the 0, 0 coordinate, you actually don't get to see the entire square. Okay, so that's the entire square. That's what it looks like. But if you plot it at the edge, half of it get covered up. Just like the thickness, when you have a thick line for a stroke, part of it will get covered up if you paint it right at the edge of the canvas. Okay, so now Waikit's plan is to make a star. And he's going to do that by first plotting 5 points that correspond to the corners of the star. I don't know how he's doing this. Maybe he's just like eyeballing it and like putting his finger on the canvas and then like eyeballing where the coordinates would be. He's like just tweaking it. I can see he's like just wiggling this dot back and forth. Look, it's hilarious. Anyway, so he figured out where to put the 5 points of a star. And now the question for you, my dear viewer, is given these points, these coordinates that Waikit has already found for us, how are you going to draw a star out of these points? Given your knowledge of paths, to refresh your memory, the methods you will use, I'll put them one on the line here, are gonna look like this. First, you're gonna begin path to start a new path. At the end, you'll close the path. And then in between the begin path and the close path methods, you'll have first a move to, which is gonna be like an X and a Y coordinate. And then you have a series of line to methods. So, okay, so figure out how to use the information in front of you to draw a star. If you wanna do it, pause the video to come up with your answer. I'll give you a couple of seconds to decide whether you want to do that. Okay, so if you drew a star, congratulations, you're an excellent developer of the Canvas API. Or if you just want to enjoy the show, well, let's see what Waikit did. Okay, so he starts with a begin path and then converts the first method call to a move to. Oh, he had change of mind here. He wants to preserve the points first, I think, while he modifies so he made a copy of the point plotting code. And now he's gonna make a modification to the other copy. So he first begins the path, then moves to the first point of the star, and then line to the second and third and fourth and fifth, and then finally he closes the path. And now we have a star. Woo! Nice. And then he gets rid of the point that were plotted. So now we just have a nice star. This star was stroked, and because it's stroked, we can change its color using stroke style. We can also change the width of the stroke by changing the line width, just like a rectangle. We could also fill the star instead of stroking it. If we fill the star, then it's a filled star. And we can change the fill color by using fill style. We actually don't really need the line width anymore, but